Hello, this is T Chapman 500. Welcome to Silicon Zero's demo. I thought I'd do something a bit different today. Put some more stuff from different games on my gaming channel, not just Minecraft. And yep, this is it. I've been hoping to get this game on my gaming channel. So you can rewind the video to get a look at that cartoon strip or whatever it is as we get ready to play. So let's see. Good to see you. I'm excited. Actually, you can read this. I want to see what the challenge is. To start, why not check to make sure our adder modules are working. Connect the modules so that the adder's output is 2. Alright, so we just left click the number, hold the left mouse button, release, click and drag, release. There we go. And you can pause the video to read this. I am not gonna read this. And by the way, another reason not to use the Unity engine for any games that I'm learning, because I have something against Unity now. Another reason to be against Unity is because I cannot see anything on the second monitor on the Mac OS. So yeah, I can't see OBS Studio. So that's another reason I'm not gonna use the Unity engine for gaming anymore. So let's see. Alright. So we want an output of 3. We have 2 adder modules, a number. So 1, 2, 3. There we go. Next. And we have to put the adder module in manually. Place and connect adder modules so that the output is 4. No problem. Excuse me. Thank you. Okay. Let's see. Configure the modules so that the adder output is 4. Alright, so we have to configure this. Okay, next. Seriously, digital circuits are, these types of digital circuits are kind of, oh, how do I say? This part is really easy. On my main channel, I'm actually building a 32-bit processor. Let's see. Configure modules so that the output is 5. Two. No. 3. Alright, so cut that. Number 2. There we go. So, memory. Now, this is what I've kind of found confusing. I don't have any, clocks. Now let's see, place, configure, and connect modules so that the reader output is 6. Alright, so memory slot or address 10 has a value of 6. So we would just make this 10, done, next, mem sum. Without configuring any modules, place and connect modules so that the adder outputs 7. So read ooh. So that should output 6. Oh. Take this here. Of course it would choose a route that I didn't want it to choose. So address 6 contains 5. 5 plus 3 is 8. Address 8 contains 2. I'm not sure if I did this right. The result is 7. So 5 plus 2 is 7. And apparently that's the fewest parts that I can do. Next. Okay, what's the challenge here? Run the sim forward until a latch stores 15. Okay. Alright, back to puzzle. Let's see. So, what was it? So we had 1 here. 1 plus 0 is 1. That goes into here. And that also goes into here, so that would be 2 plus 2, or actually 1, so to store would be 1, that would go here. That would result in the output of this being 2. Sorry, I went a bit too fast there. So now 2 plus 1 is 3, we'll store 3, then 3 plus 3 is 6. 6 plus 1 is 7, 7 plus 7 is 14, 14 plus 1 is 15. So we need the latch to store 15, just one more iteration. Okay. So now it's our turn to store 15 in a latch. That was easy. So we need to put 1 at memory address 3. Right? 1, excuse me. So address 3, value 1. There we go. Puzzle select. And now we get a few branches. So let's do stall. So memory address 0 and 1 to 1. Okay. So 0 and 1 need to be 1. Okay, so we'll just take that, do that. So what this does, we will write a 1 to the memory and to the latch. But the latch is currently storing 0, so 0 gets set, hold on. Alright, 0 is the current address we're writing to, and we're writing a value of 1 to that address and into the latch. So 1 will be put into the memory slot 0 on the first clock, and then a 1 will also be put into address 1 on the next clock. And we don't really need 3 ticks, we only need 2. So, yep, address 0 contains 1, address 1 contains 1. The slot name really should be address because that's what it is in real circuits. So let's do rewrite. So without configuring modules, get memory slot 1 all the way up to 8. This should be relatively simple. So, we write 1 into the memory slot, which then gets set to this adder. Actually, we write 0. Hold on. Okay, maybe this isn't as simple as I thought. Without configuring modules. So, can't do that. But I can do this. And after 8 ticks, I should get 8 into address 1. Is there any way to play through this? Apparently not. Okay, there we go. Let's do spares first. Let's see. Build a machine that doubles the value in memory slot 0. Hold on. New part ready. Subtractor module. The bad news is we don't have an adder. The subtractor is nothing more than an adder with the B input and the C in and C out inverted. So I don't see why we can't just remove a few NOT gates. Okay, read. Alright, so latch 0, store 0, 43. Oh wait. I want 0 to be here. No. Yeah. We need another subtractor module. So let's see. 43. No, we need this to be 0 minus 43. Then 43 minus negative 43 equals 86. Then we write to address 0, and that's our doubling. Okay, now for the counter. So let's see. Set slot 0 to 0, 1 to 1, etc. Okay, adder 1. Latch. So we'll just do this. Put this here, so we start with 0 stored. We just set that to the address and the data. 0 also goes into here. We add 1 to whatever's here that outputs our new storage value. And let's go. We just play the simulation through. Yeah, this is relatively easy. Okay, now we have 2 more puzzles. Let's do validation. Build a machine that beats the first 2 tests, but not the third. So memory goal is 2. Alright, so we're doubling the value first. Yeah, so read, add, write. There we go. Validating, running all tests on your machine before entering the simulator. There we go. 3 doubled is 6. The test 3 needed to be 12 in order to pass, but it failed, which means the puzzle is completed. So let's do increment. So we just need to increment each slot. Read, write. So 0, number, add, 1 plus 1 equals 2, write, to 0, and we need one more adder here. This is a little bit of a messy layout, but it works, and it's efficient. So let's run through the simulation. Alright. So finally we have cows. So it's been a while since I played this game, so well, I know we need 3 latches. Okay, so we have a comparator. This is what I get for not playing this game in such a long time. Don't really remember what the puzzles are. So we have our comparator. Okay. Each memory slot to the number of cows alive in that year. Okay. So I think this all hinges on this number here. Right, that. No. Hmm. Hmm. You know, I really should do something similar with Portal. Because I remember the campaigns all too well and I'd like to forget it. So, let's see. So, one is going into the first 3 slots. So we do need a counter. So there's our counter. Okay. So I remember that the comparator output needs to go somewhere. So 0 plus 1 equals 1. Alright. So the output of the counter can go directly to the address line. I think what I needed to do was something like this. The output to... no. Wait a minute. Um... how I... that doesn't make any sense. Was 3 it began heavy. That's not possible. I guess somebody failed biology. Alright. We need to get a 1 into this first slot. I think went something like this. No, that's not right. Alright, time for a few tests. Let's get rid of those. Oh wait, we need to do something with this number, so we need a comparator. I think we need to compare this with this. Put that output into here. Add this to this, put that to here. So 1, 2, and that's not gonna work. Somehow I remember just flying through this puzzle. Alright. So the next value should be 2. It's going to be 0. Oh, I see what I did wrong. So we need an adder here. This to here. This goes here. No. Alright, so let's try this. No. That's... We still need an adder here. So if I remember correctly, this thing can be done in 12 parts. And that is not how it's done. No. No, 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 no. Perhaps it's this way. No. Need to cut this line. Alright, so We'll move these out of the way for now. What we need to do is find a way to put this oh wait, I know what's going on. So adder, this, that goes back into here, but we first have an adder with a comparator. Move this stuff over. I believe this goes into here. This goes here, this goes here. This goes here. This to here, this to here. We still don't have enough modules. And this is still not going to produce the correct solution. So let's cut that. This to here, this to here. This to here. Is it really possible to solve this with 11 modules? I thought it required 12. What's the goal for this? 2, 3, 4, 6, 9, 13, 19. Okay. Did I really just solve this with just 11 modules? I think I did. And of course it would be too many modules. Okay, back to the puzzle. So I have one too many modules. Hmm. Let's see. I'm thinking that one of these adders is not necessary. Hmm. Which one of these should I remove? Hmm. Wonder what happens if I do this. Nope. So I can't remove the comparator. Or can I? No, I don't think I can. Hmm. If I remove... No, I don't think I can remove this. 10 modules. What am I missing? Hmm. I think this is the solution. Yep, that's the solution. Just one too many components for what the puzzle required. Alright, I hope you enjoyed the video. Please leave a like if you did. Don't forget to subscribe for more. And also check out my primary channel for the construction of a 32-bit computer using a digital logic simulator called Logisim. And, oh yeah, if you want to follow me on social media, you can do so at gab.com. This is T Chapman 500 signing off.